Okay, in this video in section 13.2, we're going to look at question number 6. This problem says that the temperature T measured in degrees Celsius at a point xy on a metal plate is given by the function T of xy is x squared plus 4y squared. Describe the set of points on the plate where the temperature is 16 degrees. How about where the temperature is freezing? Are there any points where the temperature is below freezing? Okay, so up above here, I have a picture of our setup. So we have some metal plate, and the temperature varies at different locations in the plate. And to measure the temperature at a given location, well, we just simply plug the coordinates into the temperature function. So as an example here, like let's say I am at the point, let's say 2, 1. Okay, to measure the temperature at this location, just plug in 2, 1 into your temperature function, and you're going to get what? Here be 4 plus 4 be 8 degrees Celsius at that location. Okay, so this is a function of two variables, right? We've been focusing a lot on level curves of these functions. So what would be an interpretation of the level curves in this context? Okay, well, here what we're going to be doing is setting our temperature now equal to a constant. So we're saying T of xy is equal to a constant. And so what this is describing, right, is the set of all points at a fixed temperature. Okay, and we're going to call those curves isotherms. Okay, iso means same, so in other words, curves at constant temperature or curves at the same temperature. Okay, so what does this translate to for this particular function? Well, this is saying that x squared plus 4y squared is equal to c. And now this is not quite the equation of a circle because I have a 4 in front of the y squared, but there's no 4 in front of the x squared. But what I can do is go ahead and divide through by c, and then I'm going to put everything under the square. And the reason for doing this is that this thing is in fact the equation of an ellipse. Notice this, if I'm going to put just the y on top, right, the 4 is going to have to come down as a quarter, and then because of the square, it's actually going to become a 2 when it's inside that expression. And this is equal to just 1. Okay, so this is the equation of an ellipse, and what we would call the semi-major axis, that would be the square root of c, and then the semi-minor axis, that's going to be, well, just half of the major, right? It's square root of c divided by 2. So this is going to be an ellipse that opens or is elongated more in the along the x-axis than on the y-axis. Okay, so one other comment, and then we'll look at the graphs of these things. Notice here, because of the square root, that our c has to be greater than or equal to 0. Okay, so we're going to keep this in mind for what's coming up. All right, so now here, these are the graphs of some various level curves, so these isotherms. So like this outermost ellipse, right, this would be the collection of all points on our metal plate at a temperature of 20 degrees Celsius. And then moving in, I'm going to get all points that are at 16 degrees Celsius, and then all points that are 12 degrees Celsius. So I get this family of concentric ellipses, right? And notice as I move in towards the origin, my temperature is going down. And in fact, at the origin itself, right, if I set c equal to 0 right here, the only solution there would be if both x and y were 0. So in fact, I'm going to be freezing just at the single point, which is just at the origin there. Okay, great. So now let's go ahead and answer the last few parts of our question. So the problem says, describe the set of points on the plate where the temperature is 16 degrees. Well, that's really just this ellipse right here that I've labeled. I've just copied it up here above. So all points on our plate that are at 16 degrees Celsius would be along this ellipse. And notice again the semi-major axis here would be 4, and the semi-minor axis would be half of that, so just 2. Okay, where are we freezing? Well, we're freezing, as we just noted down here, at the origin. Okay, and then finally, it says, are there any points where the temperature is below freezing? And the answer to that would be no. Why? Well, because of what we said back here, right? C just, again, represents, right, the fixed temperature. And since this equation is applying that C can't be negative, we're saying, in other words, there are no locations on our metal plate where we are below freezing. So this doesn't happen, or it can't happen. Okay, and that's going to do it for this problem.